Alright, look at the next one. 8620 milliliters. And we're trying to get to cubic meters, but if you look here you don't see any relationship that allows us to get directly from milliliters into cubic meters. In fact, we only have one measurement here that involves cubic meters, and that's this one down here, and it's 1 cubic meter is 10 to the 6 cubic centimeters. What that tells me is I'm going to have to take the milliliters and find a way to get that into cubic centimeters. And I can see that here 1 milliliter is equal to 1 cubic centimeter. And down here I've got the 1 cubic meter is equal to 10 to the 6th cubic centimeters. Now the way we get this is by we take the meters, we cube it. 1 meter cubed is going to be 1 cubic meter. And then we've got 100 centimeters, and all that's cubed, and 100 times 100 times 100 is 10 to the 6th, or a million. So you can see that we've got cubic centimeters down here. That'll cancel with the cubic centimeters here. Cubic meters will go up the top because that's what we want. And the relationship here is 1 meter cubed is equal to 10 to the 6th cubic centimeters. And that's how we're going to end up with our answer. Now looking at the significant figures, we've got 3 significant figures here. So we end up with 3 significant figures in our answer. You can see the 0 here is not significant because there's no decimal point in the number. So we've got 0.00862. The 3 zeros here are not significant because they're leading zeros. There's no 0 afterwards, so it's 0.00862. That's 3 significant figures. These here are temperature conversion problems. I'm not going to go through the math about how you do those, but I will talk a little bit about the significant figures. Because we're dealing with something that strictly involves addition and subtraction, I know that there's numbers you're multiplying by, but those numbers do not count as far as significant figures go. So we're only ever going to be looking at the number of decimal places the number has. So here we've got 0 decimal places, so the answer we're going to come out with will have 0 decimal places as well. So it's going to be minus 78 degrees Celsius as opposed to something that's going to have more decimal places here. I know this has 3 significant figures, but it has 0 decimal places, and that's what we go with when we do temperature conversions, is number of decimal places. Likewise here, the answer for this one is actually minus 40.0 degrees Fahrenheit. This is the point at which the degrees Fahrenheit and degrees Celsius are equal. This has 1 decimal place. The answer is going to have 1 decimal place as well. We'll go down here into the 150 K into degrees Celsius, and we're going to come out with minus 123 degrees Celsius. We've got 0 decimal places here, and the answer here is going to come out with 0 decimal places. So that's how we come out with minus 123 degrees Celsius.